the next example, I want to show you that sometimes derivative is undefined or does not exist. Sometimes derivative at a certain point is undefined, which is in short denoted DNE for does not exist. And here's an example. Given function f of x equal absolute value of x. What is the derivative at 0? How can we calculate that? Let's try to find this derivative by using the same method like we had before. So f prime of 0, because we only needed at 0, so I will use 0 and not x. So f prime of 0 is limit as h approaches 0 of f of supposed to be x plus h, but we have 0. 0 plus h minus f of 0 and divided by h. And now we need to calculate this limit. So what is f of 0? F of x is absolute value of x. So f of 0 is absolute value of 0, but absolute value of 0 is just 0 again, so just 0. Now what is f of 0 plus h? First of all, 0 plus h is the same as just h. And what is f of h? F of h, it's like replacing x with h, so it will be absolute value of h. So we're talking about limit absolute value of h minus 0. But absolute value of h minus 0, anything minus 0 is the same thing. So we get limit as h approaches 0 of absolute value of h minus 0. But this is just absolute value of h. And now on the denominator we have h. So this is what my limit is. Limit of absolute value of h divided by h as h approaches 0. And now we have studied this limit. In fact, we calculated this limit numerically. It wasn't h, it was x, but x is just a letter. So we did it numerically. And we know that this limit does not exist or undefined. And the reason why this limit is undefined, we did it numerically, is because the limit on left and limit on right are not the same. So because limit as h approaches 0 plus of that is 1, and limit as h approaches 0 minus limit on left-hand limit is negative 1. So this limit is undefined, or does not exist, and since the derivative equals that limit, so the derivative also does not exist. So this is an example of a situation when derivative does not exist. Now this situation when derivative does not exist can be nicely illustrated on a graphically. So I want to present you, I want to show you the graphic illustration. So graphical illustration. I just want to calculate, I want to draw the graph of the function. The function was f of x equals absolute value of x. So I want to draw the graph y equals absolute value of x. This graph, you can use graphing calculator to do this, or you can just do it manually. It's well known that the graph of such a function is it consists of two straight lines at 45 degrees. Y equals f of x. And now when we talk about derivative at 0, so this is derivative at this point. And the point is 0, 0, because absolute value of 0 is 0, so derivative at this point. Now how can you tell that the derivative at this point does not exist? Because derivative is the slope of the tangent line. Now can you draw a tangent line to the graph at this point? In fact, the graph makes a sharp turn at this point. It makes 90-degree turn. And what this means, it means that there is no way to draw a tangent line. You could draw a tangent line to one portion of the graph, then it will be like this, or to other portion of the graph, but there is no way to draw a line so it will be tangent line to both of them because there is a sharp turn at this point. So let me write what I just said. This is sharp turn. And sharp turn means that there is no tangent line. And no tangent line means that there is no slope of the tangent line, because slope of a line doesn't exist by itself. It should be slope of a line. No tangent line means no slope. And no slope means no derivative, because derivative equals slope of the tangent line. If there is no tangent line and therefore no slope, that means no derivative. In other words, f prime of 0 does not exist. Does not exist. So actually it's a very common illustration. Whenever graph of a function has a sharp turn like this, or maybe like this, so at points of sharp turn there is no derivative for the same reason. You cannot draw a tangent line. Or sometimes it happens that the tangent line is vertical. For example, the graph may look like this. So that there is tangent line, but this tangent line is vertical. Tangent line is vertical. And again, from algebra we know that vertical line is the only type of line that has no slope. So the slope is undefined. Slope undefined to DNE. And since the derivative equals slope of the tangent line, that means the derivative is undefined. So f prime of a, again, undefined or does not exist. So here are the situations where derivative of a function may not exist at a certain point. When the graph of the function makes sharp turn, like the graph of the absolute value, or when the graph of the function, actually it's also kind of sharp turn, so when the graph turns like that, so that the tangent line is vertical. So these are two situations when the derivative may be undefined.